Spatial Information and Urban Analysis, a study through demographics and land data. Introduction. Cities are living organisms, constantly evolving in response to population growth, migration, economic activities, and environmental factors. For planners, architects, and policymakers, understanding the dynamics of urban systems requires more than intuition. It requires spatial information analysis, which integrates demographic and land data into meaningful insights. Spatial information, when studied systematically, allows us to interpret the city overview, zonal details, road networks, and traffic volumes, and to design approaches for sustainable and equitable spatial planning. The analysis relies on both graphic data, maps, plans, GIS models, and non-graphic data, statistical and textual information. Together, they form the backbone of urban research and decision-making. 1. Spatial information, meaning and significance. Spatial information refers to data that is linked to a geographic location. In urban studies, it connects demographic patterns, land use, infrastructure, and environment to physical space. It helps answer questions like, where do people live? How is land utilized? Where are the traffic bottlenecks? Which zones need redevelopment? It bridges the gap between urban theory and practical planning, ensuring that policies are rooted in real-world conditions. 2. Demographics and land data, core components of urban understanding. A. Demographics. Demographics provide insights into the population structure of the city. Size and density identifies crowded zones versus underutilized areas. Age distribution highlights the needs of different groups, youth-centric facilities versus elderly care. Socioeconomic profile reveals income levels, employment sectors, and literacy rates. Migration and growth trends indicates how urbanization is reshaping the spatial character of the city. B. Land data. Land-related information forms the foundation for spatial planning. Land use patterns, residential, commercial, industrial, recreational, agricultural, land ownership, public versus private holdings. Land value analysis indicates demand, speculation, and development potential. Vacant and underutilized land helps planners target areas for renewal or infill development. 3. City overview and zonal details. A city can be understood as a mosaic of zones, each with distinct characteristics. Spatial information allows detailed analysis of residential zones, typology of housing, density, affordability, commercial zones, central business districts, subcenters, retail hubs, industrial zones, location, environmental impacts, integration with transport, recreational and green zones, parks, open spaces, water bodies, ecological reserves, institutional zones, schools, universities, hospitals, government offices. Zonal analysis ensures balanced growth, avoids overburdening certain areas, and supports equitable distribution of infrastructure and services. 4. Road network and traffic volumes. The road network is the city's circulatory system. Studying it involves hierarchy of roads, arterial, subarterial, collector, and local roads. Connectivity analysis, accessibility to workplaces, markets, and public facilities. Traffic volume studies, assessing congestion levels, peak hour pressures, modal splits, car, bus, metro, non-motorized. Accident-prone zones, identifying unsafe intersections or bottlenecks. These studies support the design of transport-oriented development, TOD, traffic management strategies, and sustainable mobility plans. 5. Approaches for spatial planning. Spatial planning uses demographic and land data analysis to guide future urban growth. Key approaches include land suitability analysis, evaluating physical and socio-economic conditions for development. Zoning regulations, allocating specific land uses to avoid conflicts. Transit-oriented planning, linking density and land use to public transport. Environmental sensitivity mapping, protecting wetlands, forests, and flood-prone areas. Smart city approaches, integrating ICT, real-time data, and digital tools to optimize services. Participatory planning, involving citizens in shaping local plans to ensure inclusivity. 6. Graphic data and non-graphic data, graphic data, maps, topographic, cadastral, thematic, GIS models, land use, transport networks, environmental overlays, remote sensing images, satellite data for land cover, urban sprawl, diagrams and charts, flow diagrams, mobility patterns, land use overlays. Function, visual representation makes it easier to understand patterns, identify spatial relationships, and communicate planning decisions. Non-graphic data, population statistics, census, surveys, land records and property values, policy documents and planning guidelines, environmental data, rainfall, temperature, air quality. Function, provides quantitative and qualitative depth to the